Hi guys, this is Andy, the GD script dude, with the first video in the series of the Godotia Defender clone development series. The first thing we do here is create the terrain scene and script. But before doing that, I've gone ahead and created quite a lot of code. I've got quite deep into the game development already, so I may as well show you what I've got to so far. See, this is the green terrain that we're going to be creating in this tutorial. And there's a plane, there's UFOs, and there's various items which I'm calling structures, which I place on the flat parts of the terrain. And it's got keyboard control. We can move across and go through it and turn around and go fly in the other direction, move our plane around, and we're going to shoot at these UFOs later. But for now, let's go back to creating the script and the scene for this green line, which is the terrain. So in our project, we've got various files. We've created a Godot engine, like a new project called Godotia, and I'm uploading all this code and stuff to the repo online, which I'll link to in the description of the video. But for now, let's look at the terrain, which is a node 2D. It's based on a node 2D, and clicking on this, we get a node there, and its first child is a line 2D, so we can define our line, up and down line, which is the terrain, and we give it a color by simply selecting a color. I've given it like this bright green color, and it's going to be 1 pixel in thickness, and there's a pool vector 2 array of all the points along this line, so lots of straight lines joined by points. And I see there's various advanced things you can do for lines. You can like fill them with gradients and textures, and yeah, there's capping. The ends of the lines can have different endings, but we don't have to care about that. We just want straight lines joined by points. And this line will also have an origin point, which I have placed there for some reason. It doesn't matter. Anyway, it's okay because we'll reset it later. I don't know. Anyway, let's move on to the script. We click there to get to the script. So, as I said, it extends its parent node of node2D, and I've given it a class name of terrain. This helps us in the main script up there when we want to refer to it, so the engine can easily suggest like what we want to type in for the methods, the properties of this class. There'll be terrain.line, and base level, for example, will be understood by the editor, so we don't have to remember them ourselves. We kind of remember them, but as we type, it suggests what we type in if you give it a class name. Anyway, the important things are the line. So this script is attached to here, the root of this scene, which is the terrain, and its first child is this line 2D. So we want to let's store a reference to it with var, a variable line, and then in the ready function, when the child nodes are established, we can assign a reference to this line, so we can access it. Instead of going $line 2D every time, we can just go line dot whatever. So we're gonna store the reference to the line in this way by going line equals $line 2D. The other way is with get node, the get node function, get node with a string of line 2D as its input parameter. And we got that reference. The next thing important thing we want to know is the base level. This will be used in other scripts to position items, to position structures on the flat parts of the terrain. So we want to set this base level, and we're going to declaratively call the function set base level, which we define here, and the base level is equal to it's going to be near the bottom of the screen of the viewport. So we're going to get viewport rectangle. We'll call that function, which gives rectangle viewport get viewport rectangle, get viewport rect, which gives us a point, which gives us xy coordinates of the size of the viewport rectangle, and we get the size and the y part of it. Like in games, the coordinates of the viewport are 0, 0 in the top left corner down to the maximum dimensions of x and y in the bottom right corner. But we only want to know where the deepest part, the lowest y coordinate is. So we get it via this way. We go get viewport rect and then the size and dot y. And then we want to position our green line starting at the base level, not right at the bottom of the viewport, but a little bit higher up, which is actually like subtracting something from it. And for convenience, we're going to go with our grid size, which is we're going to have a 16 by 16 grid for positioning points of our moving grid of our moving line, a ground level. So it's going to go like in steps of 16 up and down, and the left and right, towards the right. So it'll be, all the points will be on a 16 by 16 grid basically. So the start of our base will be 16 pixels up from the bottom of the viewport. Then what's next? We're going to position our line. The starting position of the line, this line 2D, will be, go back to the script, we go line dot position. It's got a position property. Click on line and look at the transform, and the position, hover our mouse, and you can see it's got the position property. At the moment we've got this crazy value of 202, whatever that means, and x equals 0. X equals 0 would be right at the edge, that's where we want it, but the y has to be set. So we go line dot position y equals our base level, which we've just calculated there as 16 pixels above the bottom of the viewport. Alright, and then what we want to do next, let's have a look at the scene. So we could click here and we can see up there we got the ability to add points to our line. Let's move this over there. We could add points. So if we click, 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 we can create a terrain manually. But I don't want to do that. I'll go Control Z to go back and even do that, so I don't upset the code base that's already there. But what we want to do is procedurally generate all the points in the terrain. This will be like, so it's automatically done, and we can do it. We can create thousands of points automatically. So what we're going to do, we're going to use the random number generator, and these operate with a seed usually. So we're going to set the seed, like in this case I've set seed equals 7. It can be any number, really, any integer, and like from 3,000, 300,000, whatever, 56, whatever, minus 27, anything. Just this makes it deterministic. It means that each time it generates its sequence of random numbers, it will be the same. Usually, if we want to have it different every time, you would have a randomize. You call the randomize function in the ready function there. That would like seed it with the current time, so it's going to be different every time someone plays the game. But in this case, we want it to be predictable. And if you didn't have randomize, it will be predictable, but it would always be the same for every game, and it may not be what we want. So in this case, we're defining our own seed value. Now we can play around with different seed values to see what it produces and if it is what we like. And then we can set it in stone. In this case, I've set it to 7 after experimenting around with different values. So now let's look at the randomized thing. What we're going to do, we're going to add points. So in the ready function, we've defined our reference to the line, and we've set our base level by calling this function the start point of the line. And next we're gonna when we resize the window, this base level should change, because if the window gets bigger, then we don't want our base to be in the middle of the screen anymore. We want it to be moved down to the next lower place in the viewport. So we're going to connect a signal which is emitted from the root of the scene, and to do that we go get tree, get root, and then connect the size change signal to somewhere in this script, and we're going to call it set base level. Well, we already defined that signal, didn't we? We already defined that function, so we can connect to our function to make it rerun the function anytime that the window size is changed. So that's what that line is about. And next we want to add points to our line to define the terrain. So this is this is called like procedurally generating things, like procedurally generating foliage, planets, etc. In this case, we're procedurally generating our terrain rather than manually generating it. So what we're actually doing is adding points to the line 2D points there. This array of points. So our function starts off with defining a random number generator, which we're calling var RNG, and we go random number generator.new, and then we set the seed with our constant value of the seed, which we defined up there. And then let's start off with the first position of 0, which is like the beginning point of our line. So we add this point, and again we need a function for adding the point. So we can have a look. We define the function add point, input p, and the point is a vector 2, and we go x, y. It kind of makes a new one rather than being a reference to the existing value that was passed in. And then line, which is remember we referenced our line 2D there. So we call the add point function on this line, and we add in our points. That becomes the first point. And then, not only adding points, we want to keep track of the flat areas of the terrain. And a flat area will be defined as where the next point has the same y value, like vertical coordinates, as the last point. So we want to make a note of that, so later we can make use of it for placing structures on the terrain. So we go if last point and last point dot if last point means like if last point is actually already defined, otherwise we won't bother doing this. If there is a last point and the last point y value is equal to the new point's y value, then we got a flat position. So let's add to our flats, which is an array to store these flat points. So we go flats dot append this point. So we're going to remember all of the flat points. And then we're going to reset the last point to this current point. So next time we come into this function, last point is available for this comparison there. Alright, so we've added our point, and yeah, we call this add point function. And next we're going to, what are we doing here? We're doing the while loop, and while the position of the x is less than, okay, we're carrying on going through all of, we want to make enough points, right? We want to make at least this minimum number of points. We use a while loop rather than a for loop because we want to finish creating points when we got back to the initial level of 0. Otherwise there'll be a disjoint as we scroll around the terrain. You know, we don't want to have a disjoint. They've got to like connect again at the end of the roll around point. So we go, if it's less than the minimum number of points, then we still need to create new points, or and say it is already reached this number of points, but we're not at 0 yet. We have to keep going. So this means if we have enough points, and imagine in logic the opposite of or is and, so and if we were already at 0, like it's not greater than 0, we would quit this loop. We finished, we got enough points. But while we're still doing it, we increment the x value by the grid size. Like in this case we set it to 16 pixels, so we move to the right by 16 pixels, and then we calculate, and then we get a new value for y, which may be up or down or straight ahead. Straight ahead is a flat, and then up would be up a slope or down a slope. And what we get our random number generator, and we do random integer, and then percent with 3 means it will produce a number between 0 and 3, 0, 1, or get that right? No, 3 is not inclusive, so it's 0. A random number integer a random integer of 0, 1, or 2, and then take away 1 to give us a range of -1, 0, or 1 for the pos y increment. So we're going up 1, straight ahead, or down 1. And then we want to limit the range of y, don't let it get too far out, like the mountain gets too big, or it goes below the ground level. So we have apply a clamp. So we get our input, our position that we just got from here. Then if it's too high, remember going up in the screen is negative, so we have this negative there, or it's below the ground level, we clamp it, and so it's clamped to 0 or the minus max height, and then we add our point. And this statement at the end, after we've finished getting all our points, it tells us in the output window what is the end position. So we wanted to have 5,000 points, so it should have like 5,000 POSIX, sorry. It'll tell us the, yeah, it'll tell us give us a feedback as to how far to the right it went in pixels and how many flats there were. And then by juggling around our seed value, we can get like a nice value for a nice number of points, depending on which seed value we use. And like I said, I've already experimented and used 7, and it gives about 5,000. A 5,000 pixel width play area, and I don't know, I forget, 128 or something flats. So I think that is it for this tutorial, and next we will, this covers the, oh, just a minute, we can run we should always run our scene. Control S, save it, and then click here to run the scene. Just checks if there's any bugs. See, there's already one there. I've messed something up. And what would that be? I don't know. But it doesn't matter. It works. It doesn't have any bugs. Debugger. See, nothing. And yeah, so it's working, and then we can play our game. I've messed something up just at the beginning. Probably by putting that. What have I done? I don't know. It's gone away probably. Anyway, I'll see you in the next tutorial hopefully, and I'll cover more about maybe the structures and the main script or something like that. Okay, over and out. Like and subscribe. See you. Goodbye.